Welcome everyone to an Android Developer Lab Plus. For those of you that are joining us for the first time, Android Developer Lab Plus is a show where we sort of do deep dives in Android topics. So this week we're talking about the Maps API version 2 that we launched for Android late last year. We did a sort of an introductory dive into it, and this is a little bit deeper into some more advanced topics. So firstly, let me introduce myself. I'm Ankur Kotwal, and I'm a developer advocate on the Android team, and I'm joining you from Sydney, Australia. I'll pass it over to Jan Felix, who's next.
Yeah, I'm Jan Felix Schmarkert. I'm a developer programs engineer on Android. I'm also based in Sydney.
Hi, my name is Tony Chan. I'm also a developer advocate, coming here from Hong Kong. So, hello.
Great. Yep, great. Thanks, Tony. And Jan Felix. So Jan Felix is one of our newest recruits. You've probably seen him on the Santa Tracker video. And if you haven't, please go and have a look at the Google Developers Live Presents Santa Tracker for Android, which heavily uses the map view API that we're going to be discussing today. So that particular session kind of goes into more the process behind building the app, the vision, and really how we made full use of the map view API library. So with that being said, let's now move on to today's presentation. And so Jan Felix, perhaps you can get us started. Are you able to see the slides just to confirm?
Yeah, looks all good from here.
Okay, all yours.
Okay, yeah, so the last ADL Plus was giving you a bit of an introduction into the map view, kind of getting started, getting your first project up and running, getting the API key and stuff set up. And so we thought this week we would look at some of the more advanced topics. So we are, if we go to the next slide, we're going to actually show you a bit of code. We're going to show you a few examples as well. So we're going to talk about info windows, because there are different types and different ways you can create info windows. We're talking about polylines and polylines. We're talking a bit about camera animations, because that's one of the really cool features and something really cool. It's really impressive in the new map view. We're going to talk a bit about markers as well, and in particular custom icons that you can have on markers. All the demos and all these samples are actually from the map view demo project. So if you want to follow along and want to look at it later on, you can just get the demo project from the SDK and just look at the code from there. Okay, and I think with that we can dive into our first topic. So info windows. I'm sure most of you have seen these before. So an info window is basically a pop-up that's attached to a marker. So when you click on a marker, that's when the info window pops up. And one thing here to remember is that you can only have one info window at a time. You tap on a marker and you get one of these pop-ups. So let's look at the demo. There are different types of info windows you can set up. So you tap on it and you get, that was the default info window you can get. There's a custom info window contents, and you can also have a complete custom info window. And we're going to talk about them in a bit more detail now to show you how you can actually go about creating them and setting them up. So
Jan Felix, sorry to cut in. What I might do is just play that one more time, because they go a little bit quickly. So,
sure.
Just talk us through that video again, could you?
Yes, sure. So the first thing, we have a default info window. We have a title and a snippet. Then we have a custom info content where we have it looks like a normal info window, like the default one, but we have our own content in there, our own layout. And this is the custom info window where we have our own layout, we have our own background. It's completely done by us. But we have some more examples later on in the presentation. You can see exactly what it looks like and what the differences are. So let's look at info windows in more general. So as I said, there are three different types: default, and the default one is basically where you have a title and snippet. So it's basically just plain text. You can't really customize it any other way. You can specify a title, you can specify a snippet. When you tap on a marker, that pops up. Custom contents, that's where you can actually replace a content that goes inside an info window. So you keep the bubble, that's the default info window, but you can actually put your own layout in there. So you can arrange the text in any way you want. You can put your own views in there and so on. And a custom info window is where we completely replace the entire info window. So you can, have your own info bubble, use your own background, and make it look and style it how you want it to look like. So let's look at let's start at the beginning. Let's look at an example for one of those default info windows. On the next slide, on the slide here, basically all you have to do is you have to add a marker. Obviously, you have to set the position, and you just set a title of the snippet. And as soon as you set the title, the map view knows that you want to use the default implementation of the info window. So in this case, it automatically knows that you have a title in bold, and you have a snippet there in the lighter gray color. And that's all you have to do, and that's your default implementation. So it's really easy to get started with that. But what if you want to do something a bit more advanced, and you want to put an image in there, or you want to style the text a bit differently, or you want to have different text views in there, you want to update? That's where the custom content comes in. And the basic idea is that you keep the default info window bubble, so you don't have to worry about adding the outline to it, making sure it's sent and all that kind of stuff. You just supply a view, a layout that's basically what's drawn inside that info window. So if you look at some code, let's look at the layout. So basically what we're doing here is we are using a normal layouts XML file that you've used before. In this case, we have a linear layout, and we have an image view in there, and then we have another another linear layout with a text view and another text view in it. And basically all we're doing, if you go to the next slide, is we're basically just inflating that and returning that. And the way you go about this is by using an info window adapter. And when you basically have to register this info window adapter, you have to create a new info window adapter. And basically there are two methods. There is the get info contents and get info window. When you just want to override the content of it, all you have to do is return the view you want to have in your info window from the get info contents method. So whatever you want to put into the info window, you just have to return from get info contents. And in our case here, the render method that we're not showing here, all we're doing there is just inflating a layout, just as usual. We're setting our text view, we're updating the image view, setting the image, and that's all we're doing. Then we're just returning the view at the end. And that's how you can have a custom content in the info window. If you go to the next slide, you can see this is a custom window, and you can see we have a bit of a gradient in the background, so the info window is a bit of a gradient, and the corners around as well. And basically it's the same idea. You just supply a view, and that view gets drawn as the info window. So you don't get the default bubble around it. You just get your view that you've returned. So if you look at the code, the only difference, the only thing we have changed is we've basically added a background to it. And the trick is to you should use a 9 patch for that. So 9 patch means that the image gets scaled up automatically and stretched in a way that makes sense. In our case here, you're stretching it so that you always have the gradient at the bottom, and you're not stretching it past the little nose at the bottom that sits on top of the marker. And that's trick to it, and that's your custom info window. If you look at the code for this, again we're using an info window adapter. But this time we have to return the view from the get info window method instead. So you have to return null from get info window contents. Otherwise, that's the one that's going to be used. So if you return null there and you return the view in get info window, that's all you have to do, and that's what gets drawn instead. Yeah. So. It's really quite simple, right? So you know how to inflate a layout. You've used layouts and views before. But there are a few issues with info windows, a few things you have to be aware of. One really big thing is that info windows are not live. So it's not like any other view, or it's not like other views you've used before. So basically, the info window gets rendered to a canvas beforehand. So you can't change the text on it live. You can't change the image. You can't have custom controls on it like other buttons or something. So you have to be aware of that. So you can't change the text on it unless you recreate the info window, you hide it and display it again. And because it's rendered in such a way, you also can't have other listeners on it. So all you can do is you can register an on info window click listener, and basically you get an event back somebody taps on the info window. So by default, it just hides the info window. But that's how you would hook into that. Yeah, that's it all about info windows. And I think now we have Tony telling us how to draw an Android in Sydney.
Actually, Felix, before we just go ahead, I'm just going to go back a couple of slides, just point out a couple of things here. The interesting thing is on this custom window you showed, you mentioned that we have a gradient and we can provide our own border for this, and you showed us a 9 patch here. The important thing to realize here is things like the shadow for the window is something that we've added in our 9 patch itself. It's something the library won't add for you, right?
Yeah, that's right. So if you want to have a shadow behind it or anything else, you want to change the background color, you have to do it yourself. You basically have to provide a different image there. Yeah. Yeah.
So it takes your image verbatim, including the little the triangle that you see at the bottom that shows that this is the marker that it's coming from. So just keep that in mind as you use these more advanced info windows, that you provide everything. The more custom you go, the more you have to provide as well.
Yeah, that's right.
Okay, thanks for that. Tony?
Yeah, thanks, Jan-Felix and Anchor. So for polylines and polygons, we do have some samples in our sample project, but it's kind of only showing like lines and rectangle or circle. So I want to do something a little bit more interesting today, and so to show you guys how to draw an Android figure on the map. So next slide, please. So before that, let's go take a look at a quick demo. So this is an Android centering on Sydney, so we can just plan around and move it. And also we can treat the color, the transparency, the alpha a little bit. Right now, changing the color. And then we can adjust the width of the borderline as well. So it's just a quick demo showing what you can do with polylines and polygons. Next slide, please. So basically, what polylines and polygons do is allow you guys to draw shapes on the map. One thing is very important is the location, the points you specify is in a particular order. So we will talk about a little bit more about that later. Basically, all these location coordinates are latitude and longitude. Polylines will display as line segments, and for polygons, it will gather just form lines enclosing an area and create a shape. But pretty much both of them are built from coordinates from points. Next slide. Yeah. Both polylines and polygon, they share some common properties. For example, you can change colors, the width, and the visibility of those objects. And for polygons, because it's a shape, so you can also change the fill color as well. Next slide. So here's a quick code snippet to show you how to add a polyline on the map quickly. It follows the same pattern of just like adding markers, and so you have a Google Map object, and then you just do an add polyline, and you specify a polyline options. In this case here, you add 2 coordinates, and then it will draw the line for you. Next slide. Here's an example how you change color and width. One thing you notice is the polyline options object is will return itself after you set a particular parameter. So that allows you actually to chain all these methods. So in this example here, I can change the color and the width at the same time in one line of code. Next slide. Yeah. here another example to how to add polygons. So for polygons is also follow the same patterns. You specify a polygon options. You just need to provide a list of lat long. So here you can provide more than two points, and it will draw the polygon for you. So we'll go dive into a little bit more detail how a polygon is drawn in future slides. Next slide, please.
So Tony, I have a question here.
Yeah.
As you can see, the labels show up on top of the polylines. I believe markers are the same, right? Markers will always show on top of a polyline rather than the poly or polygon rather than the other way around.
Yeah, I believe so. And also, I also there is in the API there is a C index concept. So if you have multiple polygons, things like that, and you can actually arrange these polygons in a particular order using the C index.
That's really useful to know. Thank you.
Yeah. So one thing I want to point out for polygon is the points you specify must be in a counterclockwise order in order for the fill color to work correctly. So let me use the diagram here to explain a little bit. So if you draw, let's say you have a sphere, a circle, and if you draw a line, a circle within the area, if you draw it counterclockwise, the thing actually enclosing in that counterclockwise circle is the area actually the color is going to be filled. So in the case here on the right, you can see the circle is in the clockwise order. So if you try to imagine you're looking from inside from the back, so it's actually the outside the area is actually enclosing. If you try to imagine like what is actually enclosing within the if you draw a circle anti-clockwise. So that's why when you try to draw a polygon, you always have to think about drawing it from a counterclockwise order. So that the right area is going to fill the color you want. So it takes a little bit thinking to try to imagine the right-hand side, but this is a key something you want to keep in mind. Next slide. For polygons, you can also change the color and width, and the method signature is a little bit, the name is a little bit different. So for polygon, it's fill color and then stroke width. Next slide. One thing interesting about polygon is it allows you to create some holes. So in here we call hollow polygons within a polygon. So one thing I use this concept to actually draw the eyes of the Android. So for the eyes, you just need to specify some points so that the API will draw the circle for you. And after that, after you create those two circle polygons, you add it to the original polygon using the method add hole. And that's how I achieve the effect having a transparent eye for the Android. Next slide. So here is a little, as I mentioned before, we're going to talk a little bit in more detail how to draw the Android body. So the diagram here show like what kind of points you need to specify in order to achieve the effect of having an Android figure body. So the first point is actually on the right, top right, and then you try to draw the semicircle shape using a whole bunch of points. We will talk about how to generate these points using an equation later. And then after you draw the semicircle, you need to create a straight line on the left. So that's why you need to specify another coordinate on the lower left corner. And then the last point is the lower right corner. And after you specify all these points, the API will just connect these dots together and then fill the shape with the color you specify. Because remember, we are using the counterclockwise principle, and that's why the enclosing area is in green in this case. Next slide. So now it gets to the equation part. So how to draw that semicircle? So it turns out like if you go to Wikipedia and try to figure out a way to draw a circle or a semicircle, you will find an equation like the one showing here. It looks pretty complicated, but it will help if you when you look at a figure like this. So this is a general ellipse equation, and the psi angle is if you try to actually shift the ellipse from the x-axis. So in this case, the b is the short distance from the center point of the ellipse to the side of the ellipse, and the a is actually the longer width side of the ellipse, and xc and yc is the center coordinate of the ellipse. But the good news is, if you are not trying to draw a curve actually with an angle, you can actually greatly simplify this equation much further. So next slide, please. So if we set the phi to 0, then everything's become much easier because a lot of the sine cosine parameter will become 0 and cancel out. So we have a much simpler equation here, which is just the center point plus a cosine theta and b sine theta. So the theta part is to allow you to draw to select some points, use samples, so that you can use those points to draw it on the map. So the next slide will show you some code, how to use that equation. So here I create a polygon options. So let's say I want to draw 400 points to get the curve, right? And so in usual case, if you want to draw a circle, the phase variable you probably want to use 2 pi divided by number of points. But in this case, I just want to draw a semicircle. So instead of 2 pi, I use pi divided by number of points. And then you have a for loop going through all these 400 points and apply the equation. It's the exact same equation you saw on top, but in code. So you use the center of the city you want to point at. In this case, I am using Sydney. And then, so xc and yc is the coordinate of Sydney. And then a and b is the width and height of the Android head you want to have. So it's just some numbers, and then multiply by sine theta and cosine theta, in this case in the equation. So this way you can generate all these points for you to draw the Android figure. So I hope that helps you guys understand how to use polygon and polyline effectively. Thank you.
Yeah, thanks, Tony. That looks really quite cool. Yeah, so now that we have a few things on the map, let's talk about animating the camera. We have an example here, a little demo that shows you some of the features that you can use. This is, again, straight from the API demo. So basically, you can go back and forth between Sydney and Bondi. And the camera animates, so we change the orientation, we change the rotation, we change the tilt. You can zoom in and zoom out, and everything is animated. But if you don't want animations, you can turn them off as well. So you can jump straight to a particular location. And that's what we're going to talk about next. So if you go to the next slide, so moving the camera, so there are kind of two ways of doing it. So either you can animate the camera or you can move the camera. And animating means the camera actually moves from point A to point B, so it's animated. And to do that, you have to use on the animate camera method on a Google Map object. And basically, you supply a camera update, that's mandatory. And the camera update basically says this is where the camera should point at next. And we'll talk about that in a second. The next thing, you can supply is the duration. So you can say, okay, how long should the animation last for? And you can also register callback, so you're notified when the animation is cancelled or is finished. But if you don't want animations, you can also move the camera. That's on the next slide. So we can basically say, on my Google Maps object, move the camera. And all you have to supply there is just the camera update, which tells you where the camera is going to point at. So if you go to the next slide, let's talk about these camera update objects a bit more. So basically, a camera update object tells Google Map how the camera should move and what the camera should point at. And to create one of these, you just use a camera update factory. And basically, there are a couple of methods you can use to create one of these objects. So, for example, if you just want to change the target, so what the map is pointing at, what the center of the map is, you can use the new let long method. You just say, okay, point to this let long. If you have a couple of points you want to have on the map, you can use the let long bounce method and basically just supply a list of let long positions, and the camera update makes sure that all these points are part of the camera. You can also specify at let long and the zoom level. You can also scroll the map. So here you specify the number of pixels you want to scroll over a map. And that's animated then as well if you use the animate camera method. You can zoom in or zoom out. And that basically means zoom in one zoom level. So you don't specify how much you want to zoom in by or zoom out by. You just say zoom in or zoom out, just like you would do when you press one of the plus or minus buttons that you've seen before. You can also use zoom by and zoom to. And basically zoom by means, okay, zoom by this many zoom levels. So, zoom by 3.5 zoom levels or 10 or something like that. Or you can also specify just a zoom level rather than specifying anything else. And that's how you create one of these camera update objects that you then use for the animate or the move camera methods. And here's, on the next slide, we have a few simple examples. So if you want to move the camera to Sydney, so we want to keep its current orientation and its tilt and zoom level, and oh, sorry, in this case we're changing zoom level as well. So if you want to move the camera, we basically call the new let long zoom method on the camera update factory, and you have to specify a let long object. In this case, that's the center of Sydney. And we can also specify zoom level because we're using the let long zoom method. And all we're doing is we basically go to our maps object and say move camera, and here's our camera update. And then the camera is moved there straight away. There's no animation or anything. If you want to animate it, so here's an example. This time we're using the zoom in camera update. So we're basically zooming in one zoom level. And all you have to do is, again, on the Google Maps object, call the animate camera method and just supply a camera update. In this case, we're using a zoom in camera update object that we're getting from the camera update factory. So in this case, we're not supplying a length or anything else. So that's cool, but we actually have full control over the entire camera. So you can specify the target, you can specify the bearing, so the orientation of the camera. You can specify the tilt, so what angle should the camera be pointing at. And you can also specify zoom level. So if you want to specify all of these things, just a few of these things, you have to use a camera position builder. And the idea is you use a camera position builder to build a camera position, and then you use the camera update factory to create a camera update. So on the next slide, you will see an example that makes it a bit more obvious. So the basic idea is, first we create a camera position. So we say, okay, we're using a camera position builder, and we can chain all of these statements together. That's quite nice. So first, we have to specify a target. So what should the camera be pointing at? You can specify a zoom level. You can specify the bearing, the orientation. You can specify the tilt, the angle, and then we just build the object. They're actually they're not all mandatory. So you can specify just a few of them. So if you want to specify just a zoom level or just bearing or tilt or something, you can do that as well. So we create our camera position using the build method, and then we basically just pass that camera position object to a camera update factory method. So in this case, the method is called new camera position, and all you have to do is supply that object into the new camera position method. You get a camera update back that you can just use in your animate camera or your move camera method. It sounds really confusing, but it's actually not too bad when you think about it. You have to create a camera position, create a camera update from that position, and then you can use it to animate or move the camera. So now we're animating the camera, but sometimes you're also interested to know when the animation is finished, or when the animation has been interrupted. And if you want to use those features, you have to register a cancelable callback. And the basic idea is you create one of these callbacks. You have an onFinished and onCancelled method. Sorry, onFinish and onCancelled, and they're called when the animation is interrupted or when the animation is finished. And you just have to supply that callback when you actually fire off the animation. So when you use the animate camera method, you have to supply your camera update, and you can also supply the callback there, and that way you get notified when the animation is finished or is interrupted. Yeah, that's it about camera animations. And that we made quite heavy use of that for the center tracker application. So if you want to find out a bit more about how we use some of these features, have a look at the GDL center tracker Android session. It's quite interesting. So let's talk about markers a bit more. So a marker basically specifies a signal point on a map. So think about it like a pin. You put a pin on a map somewhere. On the next slide, you can see some of the properties you can define. So we've seen the position before. So you have to say where the marker should be. Obviously, you can specify a title and snippet. That's what's used for the default info window implementation. You can also specify whether it's draggable or not. So that means you can pick up the marker from the map and move it around. And you have an example of that a bit later on. You can also make a marker visible or invisible. And then we have the icon. So you can actually change the icon that the marker has. So basically the image. So you can specify different image you want to use for the marker instead. And if you use different icon, you also probably want to look at the anchor. And the anchor basically says how is the image placed in relation to the position we've specified. Because it's right on top, is a bit to the left, a bit to the right, and we have an example of that as well. So let's talk about custom marker icons first, because I think that's quite interesting. So an icon actually comes from a bitmap descriptor. So it's not just a bitmap; it's a bitmap descriptor. And to get one of these, you have to use a bitmap descriptor factory. So another factory, the few factory methods you can use. So you can use a default marker. So default marker is basically the standard marker you've seen on Google Map. We have an example on the next slide. You can load it in from an asset. You can load it in from a direct bitmap if you've generated it. You can get it from a file, or you can just use it from the resource using the standard Android resource folders that you can use. So on the next slide, you can see a sample implementation using the default marker. So if you just use a default marker icon, you just say, okay, here's a new marker object, here are the marker options, and here's a position, and you don't specify anything else. You're going to get a red marker there on the map. But the default marker factory method from the bitmap descriptor factory is actually quite smart. So you can actually specify the color you want for your default marker. So you don't necessarily have to always implement your own bitmaps or your own icons. You might even just be able to take advantage of this. So in this case here, we've specified, we've added a blue marker. So you just say, okay, which hue value do you want to use? So if you want to specify a value, a color value, we just use the bitmap descriptor factory dot default marker method, and there you can specify a color between 0 and 360, and that's what's then used for the icon. But a bit more interesting is even you add your own image. So as I said before, you can get it from a resource, you can load it from the assets, you can get it from a file, you can get it from a bitmap. And here's an example where we load an image in from the resources. So we basically have a drawable. It's called just an arrow here, and we use the bitmap descriptor factory dot from resource method to load that in. And that's quite easy. But there's an issue with that because these images look and behave differently from the default marker. So you might have to specify an anchor. So an anchor basically says, okay, in relation to the position of the marker, so that long position you've specified, where should we place the image? So by default, if you think back to the default marker, you have a pin that kind of points to a position on a map. And where the marker actually touches the map is at the bottom center, right? So at the bottom and 50% from the left in the center. And if you want to specify your own anchor, what you have to do is you have to specify the ratio of where it should be placed. So we have U and V values that you have to specify. And this is coming from the ratio of the image. So 0, 0 is the top left, and then 1, 1 is the bottom right. And here's an example that shows you how you can use these values. So the top right, for example, is 1, 0. And here's an example that I put together that shows you the impact of these anchor values and what they do. So we are using a default marker here, just the stock standard default marker, but we are changing where it's anchored to the lat long position. So the default is 0.5 and 1, so that's the bottom center. And as you can see, that's exactly where it's touching the map. And on the images here, you can see the actual latitude and longitude we've specified. That's the blue circle there. So if you make U and V both 0, which means we're anchoring the icon on the top left, you can see exactly what's happened here, right? So the image, the icon is actually anchored to the position from the top left. And if you put it smack bang in the middle, so 0.5 and 0.5, it's drawn right on top of the latitude and longitude. And then here's a bit offset to the right, and with 0.2 and 0.7. So you can see if you take advantage of this feature of having your images, you should be quite careful to make sure that the marker is actually drawn at the correct spot, and especially when you move around. So let's talk about draggable markers. So you can actually pick up a marker and you can actually move it around. So when you set a marker as being draggable, you get a few events back that tell you if the marker has been picked up, if the marker has been moved. And that's what we're doing here. So again, this is coming from the Maps API demo if you want to have a look at this. So this is actually really easy to do. So on the next slide, you can see some code. So the basic idea is you have to make the marker draggable. So there's a set draggable method that you have to set to true, or you can specify it when you create the marker. And then all you have to do is you have to implement the on-marker drag listener, which, as the name suggests gets callbacks when you move the marker. You have to register the drag listener. So on your Google Maps object, you just say set on drag marker listener, and you just specify the object. And then you just listen for events. So there are 3 events you get back. So you get a callback when the user has started moving the marker, so dragging the marker across the map. You get a callback when the user is finished, when he's taken the finger off the screen and the marker has been placed somewhere. And you also get drag events, so you know exactly where the marker is as the marker moves over the map. So if you want to find out where the marker actually is as it's moving around, all you have to do is just call the get position method on your marker, and that way you know where it is on a map. And yeah, that should give you enough information to get started with draggable markers. And yeah, that's all we have for this week. So you've learned a bit about info windows, you've learned about polylines and how to draw an Android. on a map. You've talked about markers in a bit more detail and draggable markers. So yeah, thanks.
Thanks, Jan Felix and Tony. So we do have a couple of questions that have been submitted on moderator, but given that we have a couple of people here that have joined the Hangout, let's give them an opportunity to ask questions first. So we have Lyndon and Gavin. And if either of you are talking right now, we can't hear you. Or maybe they're just shy, and that's not a problem. What we can do then is go to the moderator questions. So let me just bring those up. And here we are. Okay, so first question comes from Max. I need to draw a single polyline with a colored gradient onto the map. API version 2 does allow only to set a color, a single color. Do I need to create a custom tile provider and do the drawing on my own? How can I project get tile XY zoom parameters to geopoints? And Tony, I believe you looked into this one.
Yeah, sure. So basically, for this, for what you are trying to achieve, I think tile provider is probably not the right class you should look at. I think I suggest you to take a look at the ground overlay class, and so usually that's how people use this class to achieve the effect you're talking about. So you can draw into a bitmap and then add the bitmap to the overlay position, the overlay on, and then overlay that on the map. So with the ground overlay, you doesn't need to worry about all the projection coordinates. So in the ground overlay class, there are lat long parameter you can specify to specify the position, the geo points. So.
Great. You gave us a great demo of overlays, Tony, by hiding behind your overlay then of your name. But thanks for that.
Okay, sorry about that.
That's all right. We can see you now. All right, next question. Google Map View within a view pager running on seemingly any Samsung device, and I'm told any pre-ICS device yields a lingering black visual artifact when moving to another page. Any methods you know of to mitigate this problem? And this is Lyndon, who's from Bloody Australia, which is another way of saying Australia. So, Lyndon, just a couple of quick questions on this. Firstly, you said it was any Samsung and any pre-ICS device, but you said lingering black visual artifact.
Oh.
Are you able to just sort of describe that a bit in a bit more detail? Because we went through our bug trackers and we couldn't find this particular bug. So it'll be great for us to post this bug on the official bugs list for Maps API version 2, but also get some more information so we can reproduce it. And Lyndon might not have a microphone. He is typing away in the chat. So he said any non-Nexus Samsung device. So what we'll do is we'll give it a shot and see how we go. We haven't had a chance to actually go ahead and write code to reproduce this issue. We read it pretty late. So if you grab HeartFan and run it on a tablet in landscape, you'll see it. I assume HeartFan is some open source app or something along those lines. So all right, thanks for that. We will look into that, and we'll try and get back to you in the next episode and also offline. But as I said, it's something that I wasn't aware of, and when the three of us looked on the bugs, the bug list, it wasn't immediately obvious anyway. Okay, next question. Can we have free cookies? Sure. I don't know how to do that over a Hangout, but sure. Offline map fragments with latitude and longitude attached. So currently there is no API for doing the offline support. I'm not sure what the plans around that are. Currently, what the team is basically been doing is we put version 1 out there. Well, the first release of the version 2 of the API, and there's a couple of developers, Lyndon included, have been sort of putting it through its paces and reported a few bugs. So I believe that the next release will mainly be a maintenance release, but yeah, we need to look into this. So I'll raise it with the engineering team. As with these sorts of feature requests, what we can do is we can let the engineers know that this is something that users or developers are asking for, and they can prioritize the work accordingly. I'm sure they know about it already. It's just a matter of how to do it and when to do it. So yeah, free cookies. Pop on down sometime, and we'll see what we can do for you. All right, last question. Is it possible to create a shadow of the marker and its info window on the map? So actually, this is we sort of alluded to the answer to this question in the presentation itself, in that if you have a custom info window, you have to draw the shadow yourself, and you can do that as part of the image or as part of the view rather that you provide in when you set up a custom info window. And the same thing actually applies to custom markers. When you specify the image for the marker, you can go ahead and actually put a drop shadow or whatever in there. The library won't do that for you. So yeah, just a transparent image and put the shadow where you need to. Jan, Felix, or Tony, did you want to add anything to that?
No, that's the only thing you should keep in mind is the that if you add a shadow to a marker, you always need to make the image a lot bigger than just a normal default marker. So you definitely have to make sure that it's still centered at the right spot using some of the tricks I was talking about at the presentation. So make sure you anchor at the right position.
Got you. Thanks. Now, Lyndon has also asked another question. So, given holding a reference to a marker is a bad idea, is keeping tabs of hash code of markers the best way to keep track of them, so you know which marker got pressed? Sorry, info window, not markers. So, I mean, Lyndon, the way I would probably do this is use different listeners or some sort of identifier to track within your info window listener to work out which one got pressed. Having said that, Jan Felix, anything else you want to add on top of that?
Yeah, so we actually had to do that for the Center Tracker app as well, and basically we're just keeping track of it the same way. So we have registered a few listeners, and we basically just have a tag for each of the markers, so we know which marker has been pressed. So yeah, because you can only register one listener, so you can't have multiple listeners. But if you listen for marker clicks, so you know when you want to display the info window, and when you dismiss the info window, so on info window click, that's probably the way to do it.
Does that answer your question, Lyndon? Yep, you said cheers. All right, let me just do one last refresh of the moderator, and doesn't look like we have any new questions. So thanks very much for watching.
Before we end the show, so I want to answer one of the questions asked earlier in previous show about VPN support. It's a question asked by Feng Lam. Let me repeat the question here. So his question was, Android 2.8 support IPsec VPN using PSK, PAB, PAP, and MS chat, but it is not in Android 4.8. Why is it removed? And is it possible to implement a VPN client which supports PAP and MS chat, or the support is removed from in the system level? So so we don't always have the answer, but most of the time we try very hard to try to get everyone answers. So we follow up with the engineering team, and we get the following answer. So So one thing is we haven't changed anything related to authentication protocol since 2.8. So if CHAP and PAP and CHAP is supported in the system, and it will be still supported in all the Nexus images. In ICS, we do remove L2 TP only VPN support, but we also add like 3 new commonly used IPsec VPNs support. So if you experience something like PAP and CHAP is not supported in a particular device, there are a couple scenarios we can think of. One is like the VPN server you're connecting to actually doesn't support those protocols. The other possibility is some OEMs may took away such support in their OS images, Android OS images. So that's. I hope that answered your question, Feng. Thanks.
Yeah, thanks, Tony. I'm glad you reminded me that we were going to answer that question. So, anyways, that concludes the series that we had for the Maps API. So this was part 2 of the Maps series. But actually, and we're going to add it to the playlist. The Santa Tracker episode that we did on how we built that app is basically like a part 3. It's a little bit more high level. There's not as much code shown, but hopefully you're able, as developers, you're able to get some value out of it and see, some of the tricks that we employed and how we went about it. So we'll be back again soon with another topic, and please do let us know if there's special areas that you'd like us to dive into, and we can prioritize those suggestions as well. So thank you very much for joining us. We'll see you next time.
Thank you.
See ya. Thanks.